In this video, we are going to look at some solved objective questions and the amines. In the previous videos, we discussed some mechanism for synthesis of amines through Hofmann's degradation reaction, Kettel's synthesis, Cope's reaction, Gabriel synthesis, and also nomenclature of amines. Today, we are going to apply those knowledge to solve some objective questions and the amines. Don't forget to like and subscribe to the channel after watching, so you can receive every update from this channel. Which of the following is the strongest base? So amines are basic because of the lone pairs of electrons on the nitrogen. So in most cases, if amines exist in gaseous phase, their basic strength increases as you try to increase the alkyl portion on nitrogen. But if they exist in aqueous phase or in aqueous solutions, it differs. So in gaseous phase, tertiary amines are more basic than secondary, than primary, than a neutral ammonia. But in gaseous phase, secondary amines become more basic than tertiary, then to primary, then to neutral ammonia. The reason being that if these ones find themselves in an aqueous solution, the nitrogens here on the A and the B forms a strong nitrogen bond or hydrogen bond with water, which tries to render some kind of a more electronic intramolecular repulsion, not freeing out the lone pairs of electrons in nitrogen to form or to pick up a proton in the solution. But with the case of a secondary, well, it has one nitrogen or hydrogen here, so it will interact more though, but not as strong as compared here. So electrons in ammonia and primary amines are more repelled in aqueous solution than in secondary. Tertiary is listed here because it has a well-hindered lone pairs of electrons already. So this nitrogen is hindered by 3 different carbons, which also confers some kind of electronic repulsion in an aqueous solution. So in water, secondary amines tends to be more basic than any of them, but in gaseous phase, tertiary amines are more basic. The number of pi bonds in aniline is, so how many pi bonds do you have in aniline? Aniline is just a benzene ring with an amino group, which is called a benzene amine. So the benzene has 3 pi bonds in there. In addition to carboxylic acid group, amino acids also contain which of these? So amino acids have carboxylic acid group and also an amino group. This group is known as what? This group is the group found in amide. Amides have this group, and this group is called an amido group. An amido group. Which of the following should be the most volatile? So the most volatile means that which one has the least boiling point? We have an amine here, we have an amine here, we have an amine here, and alkenes. Alkenes are most volatile or having least boiling point than amine, because amines have a highly electronegative atom present in there, which forms a strong bond, making it have a higher boiling point. So the least volatile or the most volatile one is the one with the lowest boiling point, which is the IV. Question 6. Nitrogen atoms of amino group is, so amino group has nitrogen atom with 3 different groups and 1 lone pair. So it will need 4 different orbitals for its hybridization. That is 1 of the s orbital and 3 of the p orbital. So it forms sp3 hybridization. This compound here cannot represent what? So it can't represent a primary amine, a secondary amine, a tertiary amine, and a quaternary amine. The answer is D, because quaternary amines have a plus charge in which 3 carbons are bonded to a neutral or central nitrogen. But here we have only 2, in which 4 carbons are bonded to the central nitrogen. But here we have only 3 nitrogen 3 carbons here. So they can't form a quaternary ammonium salt unless we have 4 different carbons. Quaternary, as the name implies, means 4. Which is the most basic? So among these compounds, which is the most basic? We have C. So this one is an aromatic ring phenyl. This one is 2 phenyls with ammonia or amino group at the center. We have a methylamine, then also dimethylamine. So this one, in all phases, dimethylamine is more basic than a methylamine because it's a secondary amine. Now, aromatic rings are least basic or less basic than aliphatic compounds. So this one is a benzene ring with an amino group, which is less basic than an aliphatic system. So the A and the B are nowhere compared to the basic strength of the C and the D. So therefore, among the C and the D is more stronger or more basic than the C. Therefore, the most basic among these 4 alternatives is D. The most common convenient method to prepare a primary amine containing 1 carbon atom less is. So which of these gives a primary amine with 1 carbon atom less? Is it Gabriel synthesis? Is it reductive amination? Is it Hofmann's reaction or reduction of isonitriles? So Hofmann's reaction involves treating an amide with an alkaline solution of bromine, which undergoes rearrangement to eliminate carbon dioxide. It means that the number of carbons of the starting amide is going to get short by 1. So Hofmann's reaction or Hofmann's bromamide reaction produces an amine containing 1 carbon less. So the answer is C for question 9. Question 10. When excess of ethyl aldehyde is treated with ammonia, the product is. So we have excess of an alkyl halide undergoing amination with ammonia. There is going to be a sequential reaction to produce more of the amide until all the nitrogens or all the hydrogens on nitrogen or the ammonia is finished. So if one forms, we get an ethylamine. If another one comes, we have diethylamine. If another one comes, we have triethylamine. Then finally we get a tetra ethyl ammonium iodide because it assumes a plus charge. So the answer for question 10 is D. Amides may be converted to amine by a reaction named after. So amides can be converted to amines by a reaction named after a scientist called Hofmann. So his reaction is just treating an amide with a solution of potassium hydroxide or sodium hydroxide and bromine. Reduction of this compound with hydrogen in excess of nickel or platinum as catalyst gives what? So you have a nitrile or a cyanide reacting with a hydrogen in nickel. That yields a reduction of the triple bond between here. So the number of carbons must be 3. So this one is out, this one is out, and this one is not. So the answer is B. So the bond between this carbon and this nitrogen is going to be reduced by addition of hydrogens. Secondary amines can be prepared by. So which of these reactions can prepare a secondary amine? Is it reduction of nitro compound? No, this one gives the primary. Oxidation of N-substituted amides? No, this one may give a carboxylic acid. Reduction of isonitriles? Here, this can give a secondary amine. Then reduction of nitriles? No. So isonitrile is that which contains a central nitrogen in triple bond with 1 carbon and another carbon. So it has a central nitrogen with 2 different carbons. When this compound is reduced, we are going to produce a secondary amine. So the answer is C for question 13. Question 14. Which of the following amides will give ethylamine on the reaction with sodium hypobromide? So this reagent is what is used in Hofmann's reaction. So the Hofmann's reaction involves a solution of a bromine in sodium hydroxide that forms a sodium hypobromide, which produces an amine with one carbon less. So you need a propanamide to react with this compound to get an ethylamine. So the answer for question 14 is B. Benzoic acid is treated with thionyl chloride, and the product X formed is reacted with ammonia to give Y, and Y on reaction with bromine and potassium hydroxide gives Z. So what reaction is this? So what is the Z? Let's take them one by one. When benzoic acid is added to thionyl chloride, we are going to produce benzoyl chloride. If the benzoyl chloride is treated with ammonia, we are going to produce an amide, which is benzenamide. Then when benzenamide is reacted with bromine in potassium hydroxide, it means you are going to have a Hofmann's reaction, because you have benzenamide amide reacting with bromine in KOH, which means that it is a Hofmann's reaction, which produces an amine of one carbon less. So we have a benzenamide reacting with bromine with potassium hydroxide that gives an aniline. Benzenamide reacts with bromine to produce, so it's going to eliminate one carbon dioxide and get finally an aniline. What is the IUPAC name of this? Is it N-ethyl acetamide? Is it N-ethyl ethanamide, acetoethylamine, or ethyl ethanol? C and D are out. Let's have N-ethyl acetamide, then N-ethyl ethanamide. These two are very confusing, but the correct IUPAC name, they are all correct, but the IUPAC nomenclature, which is standardly accepted for naming this group is by IUPAC rules named an acetal group. So the correct name is N-ethyl acetanamide. IUPAC name of this group is acetal. So the correct name is N-ethyl acetamide. Amines that cannot be prepared by Gabriel phthalimide synthesis is. So which of these amines cannot be prepared by Gabriel phthalimide synthesis? So the phthalimide synthesis involves treating a potassium phthalimide with an alkyl halide, then the alkyl halide with a hydrazine to generate a primary amine. Because we can form really an alkyl halide from benzene ring, it is very hard for you to produce an aniline from Hofmann or Gabriel synthesis, because aniline cannot be halogenated, or benzene ring cannot be halogenated to produce a halide of a benzene ring. So aniline cannot be synthesized from Gabriel phthalimide reaction. Question 18. Methyl amine can be prepared by which of these? So which of these can give a methyl amine? Is it Watt synthesis, Hofmann's reaction, Frederick-Kraft reaction, or none of these? So the answer is Hofmann's reaction. Pardon me for the feedback noise. So the answer for question 18 is B. Question 19. Which of the following amines will give a carbalamine reaction? So a carbalamine reaction is a reaction just like a Hofmann's reaction, which is used to test for the presence of a primary amines. Carbalamine reaction is a Hofmann's reaction which produces a carbalamine or an isocyanide as an intermediate, which produces a very a mild smell. It is used to test for the presence of primary amines in a mixture. By treating a primary amine with a hot potassium hydroxide in chloroform, we are going to produce a carbalamine or an isocyanide, which have very repellent smell that determines the presence of primary amine in a compound. So primary amines will give a carbylamine on Hofmann's degradation reaction. Let's look at this sequence of reactions. The end product Z of this reaction is what? So we have ethyl amine undergoing nitration to produce a diazonium salt or a diazonium ion, which is X. Then the X is being halogenated. Then halogen is going to be replaced by the cyanide here. So as seen here, the cyanide here is going to be a nitrile. Addition of this compound is nitrous acid to an amine gives a diazonium salt. Diazonium salt plus PCl5 is a halogenation reaction which adds chlorine to the compound to produce chloride. Then replacing the cyanide or the chlorine with the cyanide gives a nitrile. When you get a propyl nitrile as the resulting compound Z. If we are to arrange this compound in increasing order of basicity, which one will come first? We have a secondary amine here, we have primary amine here, we have a neutral ammonia and an aniline or an aromatic amine. So the list of all this is this. So where we have the C, this is coming first, will be the first one. So the list is that. Then the highest is going to be secondary amine. The secondary amine is the highest of all, whereas the aniline is the lowest of all. So the aniline will come first, then the secondary amine will end last here. So the answer is C. This one will come ammonia, and primary amines are more basic than ammonia, as shown here. In general sense, aromatic amines are less basic than aliphatic amines, and even are less basic than a neutral ammonia. Which of these can be distinguished between primary and secondary amines? So these compounds, which of these can be used to distinguish between them? Reaction of primary amines with a nitrous acid gives a diazonium salt. So nitrous acid reacts with primary amines only to give a diazonium salt. So the diazonium salt is what is used or is what is produced with primary amines when nitrous acid reacts with them. So compound C, which is nitrous acid, can be used to distinguish between primary and secondary amines. Let's look at this sequential reaction, which involves an aniline being treated with sodium nitrite and HCl. These two compounds on reaction yields a nitrous acid. So reacting nitrous acid with aniline gives a diazonium salt. The diazonium salt, when replaced with copper cyanide, gives you a benzene ring with a cyanide ion. Now we have a cyanide or benzonitrile. When you hydrolyze a benzonitrile with a mild heat, then we are going to produce a carboxylic acid. So the Z is C, which is carboxylic acid. Which of the following form isocyanide on reaction with this and that? So isocyanides are produced when you treat primary amines with hot potassium hydroxide in chloroform. So which of these is a primary amine? We have here. So the answer is B. So B produces isocyanide on reaction with ethyl chloride or chloroform and potassium hydroxide. Which of the following is used as Hinsberg reagent? So a Hinsberg reagent is a reagent which is used to distinguish between primary, secondary, and tertiary amines. It involves a solution of benzene sulfonyl chloride. So Hinsberg reagent is the same as benzene sulfonyl chloride. Electrophilic substitution of aniline with bromine water at room temperature gives what? So at room temperature, when you add bromine water to aniline, you are going to in fact break down all the pi bond system to get 2, 4, and 6 tribromoaniline. Among the compounds shown here, which is the least basic? The least basic among them all is the aromatic one, which is D. So the D is the least basic among them. Pardon once again for the feedback, the noise from the feedback. Reduction of aromatic nitro compounds with tin and HCl gives. So which of these we produce when you reduce an aromatic compound or nitro compound with tin and HCl? Okay, let's continue. I'm very sorry for the noise from the feedback. So the most basic species among the following is. So which of these is the most basic species among the following? Is it A, B, C, or D? So aromatic compounds, as we said earlier, are least basic. Cyclohexylamine or cyclohexanamine is going to be the most basic among these. If nitrogen finds itself in an aromatic ring, it becomes least basic. The B is also least basic because of the resonance stability of the pi electrons in the aromatic system. If nitrogen forms part of a heterocyclic ring, it becomes least basic. So A is the most basic among these. Let's keep reading. The answers are provided at the right corner of this. So you can pause the video, read, and choose the correct answers. Okay, so let's continue. Pardon me for the noise from the feedback. Primary, secondary, tertiary amines may be separated by which of the following? So as we said earlier, the Hinsberg test is used to differentiate between primary, secondary, and tertiary amines, and the reagent used is called benzene sulfonyl chloride. Which of this is the most basic among the following? So among these, which is the most basic? We have A, we have B, we have C, then D. So the C in this case become most basic if they find themselves in an aqueous phase. So in aqueous phases, primary amines become more basic than tertiary amines. But in gaseous phase, as you increase the flanks or the carbons around the carbon, you tend to increase the basicity. And as the number of carbons on the branches increases at the hydrophobic portion or the acar portion, you again increase basicity. So question 41, the answer is C. Cyclohexylamine is a stronger base than aniline because in aniline, electron pair is involved in conjugation. As we explained earlier, aromatic compounds are less basic than aliphatic compounds or even cycloalkanes, because in aromatic compounds like an aniline, the electrons in the benzene ring are involved in conjugation, which is the delocalization of electrons in the pipe or in the ring system. The strongest base among the following is, so which of this is the strongest base? Is it a neutral aniline? Is it the one with a nitro? Is it the one with two amino? Or a benzyl one? So here it has benzene ring with two amino groups, benzene with one, then benzene with a nitro. Then here it has a benzene ring bonded to carbon before an amine. So the carbon between the benzene and the amine breaks the rule of the aromatic system. So benzylamine here becomes more basic than any of this. Electron withdrawing groups like nitro groups tends to reduce basicity because they pull electron towards themselves through negative induction. Which of the following amines does not react with Hinsberg reagent? So we have this primary, this secondary, this, and that. So the answer here is C. Because Hinsberg reagent does not react with, or which is the benzene sulfonyl chloride, does not react with tertiary amines due to the fact that they have no nitrogen that the chlorine will pick to form HCl. So it reacts with primary amines, secondary amines, but not with tertiary amines. So from here going, I would just like us to pause, but go through, pause the video and read yourself. The answers are provided at the right corners, so choose the answers or pause the video and choose the answers. Primary and secondary amines react with acid chlorides and acid anhydrides to form what? They form a substituted amide, because the amine carbon has a nitrogen. So when they react with an acid anhydride, with the leaf of the chlorine, they will form a substituted amide. The hybridization in nitrogen in ammonia is, as we said earlier, it is sp3. Ammonia changes the moist red litmus paper to blue. Ammonia is a base, so it changes a red litmus paper to a blue. Benzene diazonium chloride cannot be stored and used immediately after its preparation because it evaporates easily. So from 51 going, just pause the video and read them yourself. The answer are provided. So thanks for watching the 30 minutes video. Don't forget to subscribe after watching so you can receive every update on this channel. Thank you.